In section 2.2, we're going to actually start working with functions a little bit with what's called the algebra of functions. And the first thing we're going to do is really quick because it's so simple. It's the basic operations that we can do to combine functions. This is your basic add, subtract, multiply, and divide. And so to set this up, I'm going to need a couple functions. So we're going to do f of x is equal to x squared plus x minus 6. And then we'll also use a g of x function, which is x squared minus 9. And the functions that we're going to look at are adding, subtracting, multiplying, and dividing. So if I were to add two functions, the way we notationally do this is we will say f plus g of x. And what that really means we want to do is we want to take f of x and add to it whatever g of x is. Now we might have a number and we could plug those in first and then add the results, or we might have just our functions like we do here and we'll just add these functions together. So f of x, that's this first one, the x squared plus x minus 6, and we'll always put it in parentheses when we make this substitution. And we add the g of x function. Well, g of x is this x squared minus 9. And then from here, all we have to do is any simplifying that comes out of it. Since we're adding, the parentheses don't really matter, so we'll combine like terms. X squared plus x squared is 2x squared plus an x, and then minus 6 minus 9 is minus 15. And we have now added these two functions together. This idea works much the same way with subtraction. If we wanted to find out what f minus g of x was, what this really means we're going to do is we're going to take this f of x and we're going to subtract whatever g of x is. And again, if we had the numbers, we could plug those in for f and plug them into g and then subtract the answers. Or in this case, we've got the functions. So f of x gets replaced with, parentheses again, x squared plus x minus 6. And the g of x gets replaced minus, in parentheses again, with x squared minus 9. And this is important because in this case, the negative is going to distribute through the parentheses. When we do that, we have x squared plus x minus 6 minus x squared plus 9. Notice the sign change went all the way through the parentheses. So now when we combine like terms, x squared minus x squared is 0. We still have an x, and minus 6 plus 9 this time is a positive 5. No, it's not. Is a positive 3. And so we end up with this x plus 3 for our solution. So adding and subtracting, just adding and subtracting the parts. And as you might imagine, multiplying to be the next operation, we'll say fg of x is really saying we take the f of x function and we multiply by whatever the g of x function is. And again, if we had the numbers, we would plug them into f and plug them into g like we saw in the previous video, and then we would multiply those solutions together. But in this case, we just have functions. They're off my screen here, but they should be on your notes. F of x we know is x squared plus x minus 6. And the g of x that we're multiplying by is x squared minus 9. And because we put these in parentheses, we know that the operation is going to be a FOIL type thing where we multiply x squared times x squared is x to the 4th, x squared times negative 9, then x times x squared is x cubed, and x times negative 9 is negative 9x. And finally, 6 times x squared is negative 6x squared, and 6 times 9 is 54. And so to finish this out, we combine like terms. There's not a lot of them. We've got an x to the 4th, in x cubed. The like term, 9x squared minus 6x squared, is going to be minus 15x squared. And finally a minus 9x and a plus 54 to give us our final product. The last operation, as you might assume, is division. We show this by putting f over g of x. And again, what that really means is simply we're going to take the f of x function and we'll divide by the g of x function. Maybe do any reducing if we think it might be possible. So f of x, again, we said was x squared plus x minus 6. And then we divide, put it over the g of x function, which we know is x squared minus 9. Now you remember from our previous unit when we were simplifying rational expressions, before we do any reducing, we have to factor the numerator and denominator. The numerator is x plus 3, x minus 2. The denominator is a difference of squares, is x plus 3 times x minus 3. And we see those x plus 3's can divide out. And so we have our final solution for the quotient x minus 2 over x minus 3. Now these adding, subtracting, multiplying, dividing functions, really simple, really straightforward. We either do it with the functions, or if we have the numbers, we plug in the numbers and do it with the numbers. What's a little bit more involved and a little bit more appropriate for this level of coursework is going to be section B here, which we're going to call the composition of functions. And this is where we really start to take a look at functions inside of functions. The way we'll notationally show this is you will see an f with a g of x inside of the f. In other words, we're going to replace the x in f with g. In other words, that inside stuff is going to go into the f function. Maybe it'd be better to show it with a few examples. If we make f of x equal to x squared minus 2 and g of x equal to x plus 5, we could be asked to find f of g of x. And what I want to notice is this g of x inside, g of x is x plus 5. What we're essentially asking to do is take f and replace the guts with the x plus 5. Well, the guts in f, that's the x squared. So now that becomes, instead of x squared minus 2, it's stuff squared minus 2, and that stuff is the x plus 5. We can do a little simplifying with it. Squaring it, we get x squared plus 10x plus 25 minus 2, and that just gives us the like terms at the end. So for our final composition for f of g of x, we have x squared plus 10x plus 23. Kind of visually what we're doing here, this kind of feels weird, but if you remember that function machine that we started with, we have a function machine that's g of x and another function machine that's f of x. And basically we're plugging in x into the first equation and out comes g of x. And we plug that into the second equation, and out comes f of g of x. We're plugging something in, getting a result, and plugging it into the next function. Now I want to notice something here. If we switch the order and try and find g of f of x, now the f of x is the inside stuff. So this f of x, the x squared plus 2, is what's really on the inside. Now it's g of x squared plus 2. That is now the guts of the problem, which means that's going to go into g where we see the x. It's now stuff plus 5. Stuff plus 5, and that stuff is x squared plus 2. Combine like terms, and we'll end up with x squared plus, oops, it's x squared minus 2, isn't it? Backing up. It should be a minus 2 each time. Don't change the sign. Keep the sign the same. So x squared plus 3 when we combine like terms. And I want to notice that f of g of x and g of f of x were two very different results. Sometimes they're the same, and that'll be more interesting to us later. But what's interesting here is right now, in general, they are very different results. So the order does matter. And we can do the same exact process with a number. We can find f of g of, let's do 3. And on the inside we see this g of 3. Essentially what it's asking us to do is go back to g and find 3 plugged into that. So g of x is x plus 5. So we're going to do g of 3 is 3 plus 5, or 8. That means f has inside it the result of g of 3. It has that 8. So all we need to do now is plug that 8 into the f function, into that x squared minus 2. So instead of x squared minus 2, it's stuff squared minus 2. We take that answer we just found. 8 squared is 64 minus 2, gives us 62 for a result. We could have also, instead of finding out what g of 3 was and plugging that answer into f, we could have gone up to that f of g formula that we found in step 1 and plugged our number 3 into there, and we would have gotten the same exact result of 62. Again, if we change the order, though, it does make a difference. Let's do g of f of 3, changing the order. Essentially, we first have to find f of 3. And remember, f was stuff squared minus 2. So if we plug a 3 in there, we get 9 minus 2, which is 7. So essentially, that inside stuff is 7. We're finding g of 7. And remember, g is just stuff plus 5. You should have that up on your notes a bit. What we're really saying is now 7 plus 5 is equal to 12. So g of f of 3 is 12. Again, very different from f of g of 3. The order is going to make a very big difference. So this composition of functions, this is going to be really the essential part of this video. So let's try a few more examples to help us see functions inside of functions. Let's look at f of x equals the square root of x plus 9. And g of x equals x squared plus 6x. First we're going to find f of g of x. So again, g of x, the inside stuff, inside of the f function, is that x squared plus 6x. So we're going to take that stuff and stick it into the f function. Into the square root of stuff plus 9. And that stuff is x squared plus 6x. Notice we see the g inside the bigger function. Now in terms of simplifying, you might notice what's under that square root can factor. That is x plus 3 squared. And we have the square root of a square, so this comes out to be x plus 3. Let's try and compose them the other way. Let's compose g of f of x. And this time the inside function is f. So inside g, we're going to see that f, the square root of x plus 9. So we're going to take that square root of x plus 9 and replace the x's with it in g. So stuff squared plus 6 times stuff, that stuff is square root of x plus 9. Square root of x plus 9. Only simplifying here is square and square root are inverses, so we're left with x plus 9 plus 6 square roots of x plus 9. And we have our simplified solution. Let's do another example. How about f of x equals x squared plus x, and g of x equals 1 over x plus 3. And we're going to find first f of g of x, then we'll go back and find g of f of x. So again, g of x, the inside stuff is this fraction, so we've got f of that fraction, 1 over x plus 3. So that fraction goes into replacing both x's. So f is stuff squared plus stuff. That's 1 over x plus 3 squared plus 1 over x plus 3. We could stop there. Let's do a little simplifying, though, just to practice our algebra with fractions. Squaring both top and bottom, we have 1 over x plus 3 squared plus 1 over x plus 3. To get a common denominator, we need another x plus 3 factor. Let's go with a different color. And that's going to give us 1 over x plus 3 squared plus x plus 3 over x plus 3 squared. Combining like terms, then in the numerator we have x plus 4 over our common denominator of x plus 3 squared. We have our composition. Now I'm going to have to scroll down to do the second example, the g of f of x, but you should have in your notes what g and f look like up above, so I don't have to keep scrolling. But again, we're going to have g of whatever that f of x function was. That f of x function was x squared plus x. So that's what's going into g. G was 1 over stuff plus 3, which is simply x squared plus x. It doesn't factor. There's not really any simplifying. That's going to be our final 1 over x squared plus x plus 3. That is our final composition. Now here's an interesting one. Let's say, oops, not C, this is number 3. Let's say f of x equals 3x minus 5, 3x minus 5 over 4x minus 3. And we're going to find f of x. We're going to compose this fraction with itself. In other words, f of x, that's this whole thing here, is going to be inside the function, f of 3x minus 5 over 4x minus 3. So that means each of these x's is going to be replaced with this stuff. So we've got 3 times 3x minus 5 over 4x minus 3 minus 5 all over 4 times 3x minus 5 over 4x minus 3 minus 3. To help us out, I want to get rid of those compound fractions. And if you remember from our previous unit, we get rid of compound fractions by multiplying each term. Terms are separated by plus and minus. There's 2 on top, 2 on the bottom. By the common denominator, which is 4x minus 3. 4x minus 3. 4x minus 3. 4x minus 3. And when we do that, the first sets of 4x minus 3's divide out top and bottom. And so we're left with 3 times 3x minus 5 times 4x minus 3 over 4 times 3x minus 5 minus 3 times 4x minus 3. Not difficult here, just a little bit of algebra, distributing through top and bottom. So we'll have 9x minus 15 minus 20x plus 15 all over 12x minus 20 minus 12x plus 9. Finally, combining like terms to finish it off, 9x minus 20x is negative 11x. 15 minus 15 is 0, that's nice, over 12x minus 12x is 0, and negative 20 plus 9 is negative 11. So in fact, we can reduce from there. The 11's divide out, and we're just left with x. Very interesting that this was just left with x. This means something important, which we're going to investigate more tomorrow. But for now, the algebra steps of just composing f with itself and simplifying is what we're going to be practicing on. In fact, we're not just going to compose things together, we're also going to decompose. The idea here is we're trying to identify an outer function, f of x, and an inner function, g of x. If we can identify the pieces of a problem, it's going to help us better identify the patterns we can use to solve the problem. So for example, if I have this function h of x is equal to the square root of 2x minus 3 over x plus 5, what I want to notice is we're taking the square root of stuff That stuff on the inside we're going to call our inner function, g of x. Inside the square root is a function that could stand alone, the 2x minus 3 over x plus 5, that has been stuck inside this outer function. The outer function takes the square root of the stuff, and so we will just call that x. H of x is really a composition, f of g of x, where f is the square root and g is the inner function of that fraction. So for example, if h of x equals x plus 5 to the 2/3 plus 3 times x plus 5 to the 1/3 plus 2, what you might notice is, again, we've got an inner function. A couple ways you could call this inner function. One way is we could call the inner function the x plus 5. G of x equals the x plus 5 inner function. F of x is the function built around it, which is the stuff. Delete that. Let's just get an eraser. Which is the stuff raised to the 2/3 power. So we say x to the 2/3 power. Plus 3 times the stuff to the 1/3 power. Plus 2. But that's not necessarily the only way to think about it. What if we took the 1/3 part with it? G of x could have been thought about as x plus 5 to the 1/3 power. This is probably more useful if we're trying to identify quadratic in form, because then the outer function is the x plus 5 to the 1/3, all that stuff squared, plus 3 times that entire stuff, plus 2. Both of these are appropriate decompositions. The second one's probably more useful to us, because if we can see the pattern, the composition of the function inside a function, it turns into quadratic in form. That makes it more useful to us to work with. In fact, we can extend this idea out to several variables. Let's say p of x is equal to x squared plus 5 over x squared minus 2, and the whole thing is to the 3/4 power. Now what you might notice is in the very innards this repeated thing of x squared. We're going to call that our most inner function, h of x. Then around that is built a fraction function. Call that g of x. That fraction is the stuff plus 5 over the stuff minus 2. And notice when you stick h in there, it gives you the whole thing, with the x squared plus 5 and the x squared minus 2. But then all that is built in a bigger outer function, which takes all of that stuff, we'll use f for the outer function, takes all of that stuff and just raises it to the 3/4 power. And so p of x is a combination of these three functions. By identifying how we can decompose the functions, it's going to help us as we graph, as we solve, and continue to work with these functions. So we looked at the basic operations to start out with. We're not going to spend a lot of time on those because they're easy, they go fast. But composition and decomposition are really going to be the meat of today's lesson. Take a look at it on the homework and come to class with questions.